with Hank. So Hank, I'm Zach Denning, CEO and founder. We're an AI building engineer for small, medium commercial office buildings. So what we find is building tech in offices isn't smart. So a lot of people like to talk about smart buildings, and buildings are so smart, and they're really not. They're not very robust. It's like a 1998 Honda Cruise Control is what we still have in most office buildings. And they're represented as these amazing new technologies. And what we find is they're not very robust. So the biggest change that we've had in building technology was in 1970 when they sent compressed air throughout buildings to control HVAC systems in your offices. It's like before electricity, right? So they came out in the 80s and they came out digital controls. So computers started rising up. You know, what can we do with computers and digital controls? And they came out with building automation systems. And these are smart building systems that run the HVAC throughout an entire building. They're fairly sophisticated, multi-tiered systems, but essentially designed to keep offices comfortable for most people. So we have on the background, we have this technology that's not very robust. So they're still installing pre-iPhone 1 technology in buildings today. They roll it out, they say it's amazing. When you look under the hood, it's pre-iPhone 1, it's very old. We're coupling that to a giant shortage of talent. So right now in the United States, 65,000 fewer building engineers, HVAC engineers, people that care about HVAC in buildings, 65,000 less. So what you find is a concentration of talent right now in buildings is baby boomers. They're all retiring. Guys my age, 30 to 40, usually just suck, so they're not very good. And the younger generation all wants to be Mark Zuckerberg. So nobody wants to be HVAC engineers, and it's the God honest truth. And it was funny, like the pills, right? I don't have my blue pill, red pill slide, but it's really the truth. Is what we're facing right now is we have to move to something that's more autonomous, something that can learn on its own, something that can adapt. And the next question we always typically get is, but I already have a building automation system, and this is what they look like. So this is the exact system that we tapped into in a building built less than 5 years old. That's a Windows XP laptop and a really old, like pre-Nokia device managing their brand new $6 million commercial office building that they purchased. And so then you say, okay, well, what does this automation do? And what you find is comfort control is immensely challenging. So when you look at 50 to 250,000 square foot buildings, I've never walked into one where I'm very comfortable. They're very uncomfortable. Now you go into the big office buildings downtown, like the ones we have here, and they're comfortable. It's because they have building engineers on site. There's a guy walking around, he's manually tuning this software system in buildings. He usually works in the basement or the penthouse. And when you call him, he has a blue outfit come on, and he comes out. What you find, though, is most of the time he's adjusting this control system. He's not pulling out a wrench. He's not wrenching on equipment anymore. He's actually changing settings in a control system. Energy efficiency is horribly, horribly complicated. So as we move to Title 24, we move to these new, more advanced sequences to control these buildings and use the economizers to do all that, on the back end you have these really old systems. And you have HVAC contractors trying to program on these really old systems to achieve these amazing savings. And what you find is immense runoff post-install. So what we find in brand new buildings, 6 to 8 months post-install, you have over 40% runoff of energy efficiency due to these type of systems. So they're technology problems in these buildings. They're less about hardware issues. And then finally, the programming is all proprietary. This is pre-Android world that we live in HVAC. There's no market leader. Siemens has the most market share right now, and they only have 10%. So it's like Nokia, when Nokia led the mobile market and they had their small phones and everybody bought Nokia, they only had 12% of the market at that time. Apple caught up. Apple took 15, 20%, then Android killed everybody because it's software that can go in every system that makes the hardware less proprietary. And so that's what we're still in right now, is the Nokia phase where everybody has their own individual system and it's insanely proprietary. So Hank's our solution. So when we look at these smart building systems in office buildings and other buildings, what we find is they're arranged like a central nervous system in a human body. There's a brain or Ethernet-based front end, and it manages most of the subsystems you see below. So lighting, HVAC, even security is starting to get tied into this brain now. And what you're finding is it's programmed insanely haphazardly. So just like what was mentioned before from Frontier, when they come in, that HVAC contractor's job is to get off site. Nobody's paying me for energy efficiency. Nobody's paying me to make these buildings extremely efficient. All I'm trying to do is get the system installed and leave. And so what we end up finding is they're programmed to haphazardly. We have this huge runoff, and then over time it just gets worse. And that gets compounded with now physical issues where they're disconnecting things. They're doing anything they can to just keep the building running. So we actually bolt Hank on top of that existing system, and we take full autonomous control of all the systems you see below. So what we find is that Hank absorbs all that data in through these systems. He now runs it up to the cloud, runs it through machine learning, and then he actually sends commands back down and takes full control of things like your office space, the major units controlling that office space, and he makes very intuitive decisions to save a lot of money. So how did Hank come to be? We spent a lot of time R&Ding. So what we find with building owners and commercial real estate is you really have one shot. Building owners' attention spans can be slim. You know, when it comes to energy efficiency and comfort, you got to get it right the first time. So we spent a lot of time developing. We actually launched the product originally as a read-only reporting platform, and we thought, hey, if we take this to ownership groups like Ethan Conrad, who are right in our target market with 50,000 square foot buildings, they'll buy the report. The feedback we got is these reports are amazing, but it doesn't do anything. Now I have to go spend money to go fix all those problems and pay for your report simultaneously. They just really weren't open to it. So we spent another year and we completed the loop. What we found is 75% of the problems plaguing buildings today are software-related issues. They're not hardware, they're software. So if we can complete the loop where Hank can find and solve his own problems, we can solve 75% of their energy efficiency problems, and we can save them a ton of money. My background, mechanical engineering, software developer, now data scientist. So I spent 8 months teaching myself data science. We use full applied machine learning with what we do. So it actually is autonomously learning. It's not just a buzzword. Hank actually does learn how this space would heat and cool to properly keep it at an optimal temperature. So if you like it at 72, Hank can keep it between 72.5 and 71.5. So very, very tight temperature tolerances. That's how we define comfort, which we'll talk about. And then based on what we've done and what we've proved, we started developing extremely strategic partnership groups right now with Lockheed Martin, TRC Energy Solutions, Willdan Energy Solutions, even Burns McDonnell, multi-billion-dollar design build firm. So how does Hank work? We actually assemble our own 4G LTE router or on-site utility in-house. We ship that out, and we actually have one of our partners install it. So traditionally, this process that you see here can take up to 2 weeks. We can do it in less than 4 hours. So we're actually doing one tomorrow in Kansas. So we've shipped it out. They plug it into the existing system. They call our hotline and say, hey, can you see it? We say, yes, we can. And that technician can now leave the site. From there, we download our own driver sets to gain access to this proprietary data. So these are really old technologies that we're attaching ourselves to. We spent 2 years developing drivers. We can attach ourselves to 80% of equipment out there right now. So 80% of all manufacturers, we can get both read and write access to all their data. From there, what we do is we build what we call a digital twin of every piece of equipment in a building. So in a 50,000 square foot office building, you can have up to 70 different pieces of equipment all needing to work together in tandem, all needing to talk together, and that's usually why they don't work very well. It's very hard to program that manually. It's not a manual process. So as a result, we develop what we call digital twins. So these are machine learning models, and even for a space like this, Hank will be learning how the space is supposed to control, how it's reacting to different conditions, and he starts to make decisions. So on the back end, he's able to make and find these hidden energy savings opportunities. And everybody goes, okay, well, what's a hidden energy saving opportunity? In 2 of our buildings, it was about 60 degrees outside, and Hank went into full cooling mode. And we all looked at each other and were like, okay, it's a pretty intuitive decision. Let's see why it's doing it. What he found when he went into full cooling is the building would depressurize. No comfort was affected. We got 0 comfort calls. Everybody was still really happy. But with the building depressurized now, the exhaust fans turned off. And those exhaust fans were costing the owner about $1 an hour. We did that on 4 exhaust fans for an average of 4 to 6 hours a day. And with only 1 setting change, we drove about $25 a day in energy savings for that client using a software fix. What's crazy, though, is we compound that with almost 15 to 20 changes just like that in office buildings. So these are small, subtle changes, but are very, very intuitive. that only a human would understand if they were working full-time in the building. So when we go to building owners, we tell them it's like having 10 building engineers in all of your buildings, but now it's much, much more economical. So we're actually taking all those great things of having engineers in big buildings and scaling it down, making it economical for the majority of buildings in the United States. So we take all those different changes that Hank's going to make, and we build what we call an ASHRAE Level 2 audit. Shows owners when, why, where, and how he's going to save energy in their building. What we find is about 25% of these changes are hardware physically related problems. About $5,000 to $6,000 per 50,000 square feet is what an owner can expect to spend on fixing hardware failures in their building. So a very low amount with a very high payback. From there, they go to work. And these are actual savings we saw in a 50,000 square foot building that we drove in Roseville. And it's become the norm. And we've actually seen more increased energy savings from HVAC as a result of Hank. Of these, again, only 25% of these energy savings are related to hardware. These are mostly software changes from operating the building differently. So we drove over 40% HVAC energy savings. We're up to 50 to 60, but we don't talk about those numbers to owners because they don't sound realistic. In a lot of our buildings, that's proven off of energy bills. So we actually take their energy bills, take out weather, and show them the exact savings. So this isn't just us coming up with a calculation. These are real. Service savings on the back end now. They don't have a guy continually going out there playing with settings, trying to adjust things anymore. Hank does that on his own. So as a result, we see huge, huge reductions in service savings for customers. And then as a result, the equipment doesn't work as hard, so it doesn't degrade as fast. So when we stack ourselves up against the traditional incumbents in the space, these are guys that if you wanted to jump from a Siemens system to a Honeywell system in your building, these are the expected costs. We're 85% cheaper, faster, and better than they are at getting new systems in buildings and making them work right. So our industry is terribly antiquated. We found a way to attach cloud-based services to it and have an AI run these buildings, not a human engineer. So why do our customers go with us? Why are people migrating in this direction? It's vendor agnostic. So the average portfolio owner has 6 different control systems in his portfolio. That means he's talking to a Siemens rep, a Trane rep, a Honeywell rep, an ALC rep, and maybe one other guy from some small manufacturer you've never heard of. He's talking to all those people, trying to get them all to work unanimously in his portfolio, and it never works. So we can bolt on with Hank, one front end. Every building operates the same regardless of the manufacturer. 4-hour training, so typical training classes are week-long training classes to learn these systems. We've condensed it down to about 2 hours. So it's insanely easy to learn how Hank operates. And then on the back end, we just see huge comfort improvements and savings. So comfort's relative, is what you find. So everybody always asks about comfort. Comfort is relative. I relatively like it at 72.5 degrees. That's my optimal temperature. What we do for people is we keep their office at 72.5, regardless of season, weather, sun, whatever impacts that space. Hank keeps it at that temperature, and what we find is we don't get tenant complaints. We don't get the space heaters. One of our offices, we reduced their total energy bill by 50%. They spent $5,000 in hardware fixes. We dropped their energy bill in half. And when we looked at it and found out why, it's because all the people stopped using space heaters. They put space heaters away. It's wild. We don't actually do anything with that building on a monthly basis. We may spend half an hour just double checking Hank and making sure he's making the right decisions in that building every month. That's normally a 4 to 6 hour process minimum with a truck charge that we can do in half an hour or less every month. So just drastically different than what our industry's used to, but we're making a lot of waves. So that's what we're doing. That's AI in buildings, applied AI, not the buzzword AI, actually applied AI in buildings where it actually is doing real things. So questions?
So based on the last presentation, when you have an install, do you also ask them to go check some of the obvious things of